Hello everybody and welcome to another Infinet Wireless webinar. I'm Radu Horoiu, Professional Services Engineer at Infinet Wireless, and today we are going to talk about the broadband wireless connectivity solutions for the mining industry. More specifically, I will show you some Infinet Wireless solutions for the typical applications in the mining industry. I will explain what are the benefits of choosing the Infinet Wireless products for these applications, and I will show you an example of a major project that was implemented using Infinet Wireless equipment. The session will last for about 20 minutes. As always, we will have a Q&A session in the end, but you can write your questions down in the chat section at any time. Some of my colleagues from support are also here to answer some of your questions in the chat as well. To begin, let's take a look at a typical mining site and see what are its main components. The mining operations take place over large geographical areas, so efficient data communication is mandatory in order to provide coordination between the activity centers. Companies with reliable and cost-effective communication systems that offer synchronization between field operations, central management, security, and transportation will be able to constantly adapt to changing conditions and demands. The data networks deployed inside mining sites must meet the requirements for increasing bandwidth and secure, reliable communications in harsh environments in order to achieve their operational objectives. During this webinar, we will only cover open pit mining. So in this case, the main components of the mining sites are the mining vehicles like excavators, large trucks, and other specialized nomadic machinery, trains, and monitoring centers which are used to keep an eye on the network and the operations across the entire site. Next, let's see what are the typical applications which are implemented in the mining sites. First, we have the telemetry data transmission. This includes sensor connectivity for seismic radars, dewatering systems, meter readings, and so on. The main specific needs of these applications are support for real-time data transmission and high availability. Then we have the remote monitoring and control for the mining machinery. The specific needs in this case are the same as for the telemetry, high availability, and real-time communication support. Certain SLAs must be configured per sensor and per vehicle. Next, we have the video surveillance and security applications which require low latency and support for high-quality real-time video streaming. And the last important application is the backbone connection. In this case, long-range connectivity and high throughput are required. Also, the connection must be reliable, and in most cases, redundancy must be implemented as well. The wireless devices which are installed on mining sites must be able to cope with harsh environmental conditions like extreme temperatures, wind and dust, rain, snow, and ice, and also vibrations. In the next few slides, I will show you a few examples of typical Infinet Wireless deployments for mining sites. And first, we have an example of some wireless links for mining vehicles. Typically, these kinds of networks are point-to-multipoint. The CPE units are installed on the moving vehicles, while the base station sectors are mounted along the perimeter of the open pit, usually on high towers. The vehicle should always be within the coverage area of at least one base station. Therefore, the base station coverage areas should have overlapping zones, and in order to avoid interference between the base stations, they must work on different frequencies. The sectors can be connected between each other via wired or wireless connections, and they all have to be connected to the aggregation unit. The next example is the railway coverage for the trains which are used for transport within mining facilities. As opposed to the other mining vehicles which are usually nomadic, the trains are mobile, so they move fast, and the handover process should be quick enough to ensure that at least one of the CPEs is always connected to a base station. At least 2 CPEs are required on the train. Our recommendation is to install one CPE in the front and the second one in the back. The distance between the base stations can be adjusted to provide enough coverage margin for a reliable handover process. The CPE location on the trains always provides redundant connections, forcing at least one wireless link to be live all the time. The synchronized communication due to GPS synchronization and TDMA technology eliminates the influence of reflections and mutual interference. 2 base station units connected back to back will form a multi-sector base station for mobile CPE connections. Each base station unit should have the antenna beam aligned along the rails. It is recommended to set different frequencies for 4 adjacent sectors to avoid mutual interference. Both in front and in the back of the train there will be a CPE with 2 omni antennas that have enough distance separation, or a single dual polarized omni antenna. Interwagon communication can be done using Infinet Wireless units as well. 2 CPEs are enough to fulfill this requirement. Each Infinet Wireless unit must have the Mint over Ethernet option configured in order to have a unified Mint area. And our Infimox switches will be used to aggregate the links. They will act as border switches between the Ethernet and the Mint areas, and they will also perform load balancing. And the last example is the backbone link between the aggregation center and the monitoring center. In this case, the most important aspects are that the capacity of the link must be high enough to carry the data from all the terminals, and also redundancy must be implemented in order to make sure that the connection is not interrupted. There are 2 main methods of implementing redundancy. The first one based on OSPF, which works at layer 3, and the second one works at layer 2, and it is based on our proprietary failover option. We have covered this technique in great detail during one of our previous webinars called 1+1 Load Balancing and Redundancy. You can find the recording on IW Academy or on our YouTube channel. Right, next let's see what are the main benefits of the Infinet Wireless devices in case of mining projects. And the first 2 important features are frequency roaming and radio profiles. Frequency roaming means that a CPE can roam between the coverage areas of multiple base stations that operate using different frequencies. And each CPE can have multiple radio profiles configured according to the existing base stations in the area. Now let's look at how the handover takes place without using the multi-base station option, which we will talk about in a few minutes. So when a CPE moves outside the coverage area of a base station, the link will be interrupted. Then the CPE will try to reconnect to the same base station. And only after it fails, it will try to connect to another base station. So the handover process in this case is slow. There can be a lot of downtime, and that's why we recommend using the multi-base station option. The next major benefit is the option for fixed, nomadic and mobile modes, which influence the time interval for the Mint cost updates in the Mint network. This interval is 3 seconds in the fixed mode, 1.5 seconds in nomadic mode, and only 1 second in mobile mode, which allows for a much quicker response to rapid changes that take place in the network. Next, we have the multi-base station option, which I have mentioned earlier. It can be enabled on the CPEs, and it allows the terminals to search for a new base station much quicker in nomadic or mobile scenarios. You will see in a few moments how this works. So, as you can see in this next animation, if multi-base station is enabled, when the link quality gets bad, but before the link is interrupted, the CPE will drop the link without trying to reconnect to the previous base station. Then the CPE will immediately try to connect to another base station. And so the new link will be established much faster. Right, the next important benefit is the proprietary Mint protocol. Mint stands for Mesh Interconnection Network Technology, and it is the one and only transport protocol between the Infinet devices from the R5000 family. Mint is enabled by default over the radio interfaces, and it can be configured to work over Ethernet as well by creating PRF interfaces and joining them with the RF interfaces. Each Mint node will automatically discover all the other Mint nodes in the same Mint area, and it will calculate a cost for each path towards them. When calculating the costs, the nodes take into account radio parameters like SNR, bitrate, retries, link load, and so on. In the next slide, you will see how the Mint path selection is done. But first, you need to know a few things about switch groups. Basically, the Infinet R5000 units located at the edges of the Mint area are ingress and egress points between Ethernet and Mint. The traffic can be switched only between at least two units that have the same switch group number configured. In this example, let's say that the traffic travels between the J and F units, which are in the same switch group. The Mint area includes several other units which can have different switch groups configured or none at all. The Mint traffic will be able to pass through them in order to reach the destination. So let's say that this is the first path chosen by Mint through H and G. If at some point the cost of this path increases due to poor link quality, then a second path will be chosen through C, B, and D. And if path 2 is also problematic, then Mint searches for a third option through I, D, E, and G. And the list can go on. Mint will always choose the path with the lower cost. No STP is required. The Mint network provides loop-free connectivity. And last but not least, we have the Infimox device, which is a compact network switch that has the same operating system as the R5000 devices. It supports Mint natively, so it can act as a border unit between Ethernet and Mint. It can also perform load balancing for multiple Mint links. In this slide, we have an example of a situation when the Infimox is very useful. So, as you can see in the picture, the Infimox, the two base stations, and the two CPEs are all in the same Mint area. There is a wired connection between the Infimox, the base station, and the backbone unit. There are two potential paths for the traffic to travel between the Infimox and the CPEs on the vehicle. The best path will be chosen according to the lower Mint cost. And if the backbone link is built using R5000 units, the Mint area can be extended in order to have one entry point and a single end-to-end QoS. Next, let's see what advantages the Infinet Wireless devices have in terms of environmental features. First, the temperature range can be extended to -55 to +60 degrees Celsius. All Infinet Wireless devices except the Quanta 5 can be supplied with an optional built-in heater to enable their operation in very low temperatures and Arctic conditions. These units also have a built-in sensor for the inside temperature. Then the maximum wind load is 200 kilometers an hour, which should be enough for all practical scenarios. All Infinet outdoor devices are compliant with the IP66 and IP67 ratings, so they are protected against water and dust. And lightning protection is ensured by using the optional accessories like the aux-ODU LPU-G. Right, now in the end I want to show you an example of a real-life implementation for a mining site using Infinet Wireless devices. The customer is Shubarkol Komir JSC, a mining company from Kazakhstan, which is one of the largest thermal coal producers in the country. As part of a recent strategy review, the company executives decided to introduce automated production counting and provide better security and asset management by deploying a new video surveillance system. The previous IT infrastructure, which was built using low-cost wireless solutions, was found to be unreliable and not flexible enough to meet the company's evolving needs. It was simply unable to provide the necessary bandwidth, reliability, functionality, and packet performance to support the company's growth. To satisfy the customer's requests, the Infilink 2x2 point-to-point solution was selected to provide data transfer rates of at least 70 megabits per second between remote locations. For non-line of sight conditions across the challenging terrain, the Infiman 2x2 point-to-multipoint devices were deployed to provide connectivity between the remote facilities and the strategically located base stations. With capacities of up to 35 megabits per second and fully functional throughout the -55 to +60 degrees temperature range, the solution ensured that all links were fully integrated and stable throughout the mines, with more room to grow in the future as the requirements change. The solution was deployed using 5 and 6 GHz frequency ranges, providing the company with much higher reliability than previously experienced, with multiple links operating in both line of sight and non-line of sight conditions. The added benefit from using the Infinet Wireless solutions is the seamless integration of all video streams generated from remote cameras, as well as other applications such as VoIP services, internet access, and the corporate information network. The InfiMonitor EMS was also deployed to easily manage and control the whole Infinet Wireless network. Right, this brings us to the end of the session. Now, if you have any questions related to today's topic, please write them down in the chat section and then I will answer them one by one. Right, first question: do the sectors used with moving CPEs must have support for beamforming technology? It's not mandatory, but it is recommended. Obviously, with beamforming, the connection will be much better because of the narrower beam that can be used for each CPE. So yeah, it is recommended, but it's not mandatory. Next question: the two radios on the train, they need to be connected via cable between them. You have two options, like I mentioned during the webinar. They can be connected via cable or via wireless connection as well. You can use another two CPEs just for the interconnection between the first and the last CPE on the train. Next question: how about base stations? I guess you mean that how do you connect the base stations between them? Again, you have several options. You can connect them wirelessly with XGs, for example, or wired connection, maybe fiber if possible, but it depends on the distance that you have between your base stations. What is important is that all devices should be connected one way or another to the Infimox. So at least the base stations, if not the CPEs as well, must be connected to an Infimox device. Right, next question, how fast in milliseconds is the roaming? So when you configure multi-base station and you do the optimized setup that we saw in case of the train, the handover takes place very fast, about 200 milliseconds. Next question, what is the optimal density / distance of the towers to have uninterrupted roaming connection? I cannot give you an exact figure. It really depends on the setup that you have in the field. It depends from one project to another, on the types of devices that you use, on the types of antennas and so on. It can be, I don't know, a few hundred meters or something like that, but I cannot give you an exact figure. It can be several kilometers in some situations. It depends. Next question, does Infimox exist in the product lists of Infinet? Yes, you should be able to order it. I'm not sure if you can find it on the website, but if you contact your local sales manager from Infinet, you should be able to order Infimox without any issues. Right, so again about the roaming, as Dan also said in the chat, yes, if you position your base stations correctly and you have correct coverage between -40 and -60 dBm everywhere, you will have virtually no downtime at all. The roaming will be seamless. Next question, what is the max throughput that we can deliver to the truck? And is this symmetrical in uplink and downlink? So the maximum capacity of our CPEs is 180 megabits per second over the air. That's aggregated throughput, so uplink plus downlink. But in some cases, it depends on what type of CPE do you use, because our current lineup of CPEs does not support gigabit Ethernet, so you might be limited to 100 megabits per second aggregated by the Ethernet port. If you use a CPE that has two Ethernet ports, because we also have CPEs with two ports, then you can use link aggregation. You can perform link aggregation using an external switch or an Infimox device, and you will benefit of the whole 180 megabits per second that the CPE is able to transport over the air. So yeah, the theoretical maximum throughput, aggregated throughput for a truck, for example, is 180 megabits per second with the CPE in a point-to-multipoint setup. Of course, you can also use Infilink 2x2 Pro device that can go up to 280 megabits per second, but I'm not sure if that is cost effective for most scenarios. Next question, how many subscribers can we serve at the same time? For our R5000 point-to-multipoint devices, the Infiman devices, we don't have a limit, a CPE limit, so it's basically unlimited. But of course, the more subscribers you add, the less bandwidth each subscriber will have. So if you only need a few kilobits per second for each subscriber, for sensors or something like that, you can go even more than 150 subscribers per sector. We have, I think, the maximum numbers of subscribers that we have in a project in the field is more than 160. Right, so yeah, it's great that my colleague came with this clarification about the two antennas on the CPE, the subscriber. So it means that the CPE has two base station profiles, so not actually two physical omnidirectional antennas. Right, next question about the overall throughput, the maximum overall throughput of a base station. It is 240 megabits per second. This is the maximum that a base station can support. Of course, this will be divided between all the subscribers in the sector. And this is uplink plus downlink. It's aggregated throughput, so not full duplex. Right, next question. What is the maximum distance that radio can cover? Really depends on what type of terrain do you have, what types of antennas do you use. You can find some general guidelines on our website in the specifications section for each type of device. But it really depends. It ranges from a few kilometers in some situations to tens of kilometers in other situations. So I cannot give you an exact figure right now, but this is the range from a few kilometers if you have hills and so on, and maybe tens of kilometers if you have very tall towers and clear terrain, clear line of sight. Next question, we need you to explain how we can configure the equipment to make the roaming feature work. So for these situations, if you have problems with the configuration, please don't hesitate to contact our support team at support@infinitewireless.com, and they will be able to help you with your particular situation in every case. It is very hard to cover configurations during a webinar. Another question, next time could it be on configuration of the Infinet R5000 units? We already have a schedule for our webinars for the next few months, but we will certainly take into account this suggestion maybe for the future. Right, so in the documentation for R5000 we have a section called configuration scenarios, and I will give you this link as well. Right, so I see that there are no more questions. Thank you all once again for joining, and see you next time.